Welcome to the webinar. My name is Jacob. I'm a sea ice analyst at Drift and Ice Polar Services. And I'm going to talk to you about, first off, just a brief background about drift and noise, and then move on to demonstrate IcySea, and especially focusing on the newest feature that we have, which is the ice charts from the US Ice Service. And really the plans of what's going to happen. There's a lot in the pipeline. Actually, some releases planned for this week even. So a lot of new things. And yeah, go through everything. And then in the end, if you have any questions, let me know. Okay, go. All right, Drift and Ice Polar Services. We're a small company of 8 people in northern Germany. We're located in Bremen, and we're really a spin-off company of the German Polar Research Institute, Alfred Wegener Institute in Germany. Lasse, one of our co-founders, worked in the sea ice physics department. That's where I came from as well. So we have sea ice expertise in the group, and then about half the team is dedicated to software development and sort of the IT logistics. And then Hannah is doing a lot of the administration work that we have at Drift and Noise. And yeah, together we sort of put IcySea forward, but we also do a few other things. So we're actively involved in ongoing research projects. About half of our revenue comes from researching sea ice, navigation in ice, all that stuff. And then we're also consulting clients in the field remotely, but also on board. We join expeditions, provide navigational support, as we've done so for the Endurance 22 expedition a couple of years ago that went looking for Shackleton's Endurance that sank in Antarctica over 100 years ago. And then last year, we joined the German research icebreaker Polarstern for an expedition as well. And then, yeah, the other half of what we're earning is related to IcySea and the software development part that yeah, pretty much half our team is doing. I think IcySea really came about as we were working on the bridge of ships. We usually would have to do our research projects, but given the knowledge and the access to satellite data and all that, we're always asked to join the bridge and provide satellite imagery for navigational support. And really the reason behind that is that there's a lot of data out there. We can go through a few of them. Weather data is obviously very valuable and interesting. Satellite images, there are a lot of satellite missions planned, so there's going to be a lot of new data. Various different sensors equipped with those satellites equipped with those various sensors. Ice charts are still something that people are really interested in because they're so high quality and really give a lot of detail about what's going on in certain areas. But yeah, in the past, those have been available as printouts on PDFs and you know, as pictures, and really what we're trying to do is make it available in a digital form as well. So this is what I'm going to talk about a bit later. There's a lot going on in the research world about sea ice modeling, especially drift. Drift is really variable depending on where you are in the Arctic or Antarctic. There's regional differences, and there's a lot of work being done to improve sea ice models that are really relevant for navigating ice-covered waters because it's so dynamic. Vessel traffic, of course, one thing that's important for ships out there. And then the sort of usual ice information or ice characteristics, age, thickness, in-situ measurements, icebergs, ice types, but also historical data in the cruise industry. If you're planning to go somewhere, you want to know whether an area is accessible for the kind of ship that you operate or not. So there's a lot of data out there, and usually the difficulty for navigators gathering everything in a way that, you know, is useful for for them and really makes it easy to make decisions. Usually, once you're done browsing all the internet pages, the data that you gathered in the beginning is already outdated. So IcySea really tries to combine everything into what we call actionable information. You get access to what you want and need, and then get to make decisions based on that, and really take the advantage of all the, we're going back, all the different data products. Every one of those has certain advantages and disadvantages, but the combination of all of them together is really what gives you the most comprehensive picture of what's going on out there, and makes it easier to make decisions, really tactical decisions in ICE as well. Okay, so much for the short introduction into what we do and what IcySea really is. I think I'm going to dive right into the demonstration. I'm going to move over to Chrome. IcySea runs really on all operating systems, but we found that Chrome is probably, excuse me, that gives the best performance. So we recommend using IcySea in Chrome. And I think really the first step is loading IcySea in Chrome, IcySea.app. You type in you register, and then you type in your access code, and then you have access to the map interface. And what I usually do is I download it so that I have it as an app on my device. I'm working on a Mac right now, so I have this little install IcySea button here in the browser bar. And if I click on that now, it will ask me to install it, and does so. And now, as you can see down here, I have this little IcySea icon. I can put it into my work bar down here. And now I don't have to go via Chrome anymore, but I just, if I close this, I can close Chrome and just open IcySea as a separate app. It will still access Chrome, but it's a separate app on your device. Works on Android, on your phone, on iPads, tablets, and laptop computers, and all types of computers, really. Sort of the idea behind IcySea was that people usually only had the navigation screen on the bridge, so you could only see yourself, the landmasses around the other ships, and this is really where we started from. So what I can do now is, if you see my video here, I have this little GPS mouse that I can just plug in with USB into my computer, and I can go up here to select user position. Well, first I go into the settings menu, and I tell IcySea that I'm using a separate and external device. Close this, and I can click on the user position, select my GPS connector, and it will put me right into Bremerhaven, where I am located at the moment. So this is sort of the initial starting position, and this is where we started building IcySea from, based on being able to see where you are in relation to land. And now the idea was to include sea ice information products that are useful for navigation. There's a couple of sort of features for handling IcySea. For example, if you're moving around in the Arctic, for example, like I did, you see that the orientation of the map is not towards the north anymore. There's two options to change that. There's one, the rotate to north button here. So wherever you are, you can click on that button. It will automatically rotate. The short version is to press the N key on your keyboard. And that's what I'm going to do now. So we'll just automatically put IcySea north to the top. And that's really, yeah, how navigators usually want to see the map that they're working on. There's other features like distance measurement tool that you can use to sort of get an idea of how far certain distances are. You also use that and measure sizes of ice flows, stuff like that. You can have multiple measurements if you want to, and you can get information. For example, if you're looking at a feature and you want to set a waypoint, you get the information of where that is, copy the coordinates, decimal degrees, whatever format you like. You can copy that and get the information to paste in whatever system you're working on. If I just open something up here, paste it, gives me exactly the position that we just copied. Okay, so this is sort of the basic features that we have in IcySea. And now I'm going to go through the different data layers. There's a couple that we included since the last webinar. So one's the surface temperature, which really gives you the temperature at the surface independent of what kind of surface it is. So either gives you the ocean or ice surface temperature. See the legend down at the bottom here. -25 is obviously the ice surface. And then this is really why this layer is really interesting, is once the ocean surface approaches those -2 degrees, the freezing point of seawater, you can expect ice formation very soon. We saw that really nicely last year as the Northwest Passage started freezing. Temperatures really lowered down to -2, and then within days the Northwest Passage started refreezing. It was really, if you go in an area late in the season, this is a nice layer to look at to give you an idea of when to expect ice formation. It's very colorful, so I'm going to close that now. We have sea ice concentration, which is the most updated layer that we have in IcySea. It's updated up to 8 times a day. Updates can be done here with the refresh button. So if I click on this now, latest layer was from 11:15 UTC, and there's another one from almost 1 now as well. And that really gives you the fraction of the area that is covered with sea ice. So for each one of these little pixels here, it sort of explains or gets the value of ice concentration. So this pixel here would be covered with 60%. 60% of the area would be covered by sea ice, but you don't know where within this 6 times 6 kilometer area the ice is located. So it's a really low resolution information layer. We have a bit higher resolution here with the 3 kilometer resolution that you can also put on top. So yeah, so sort of higher resolution for certain areas here gives you more of an idea of what's going on. I'm going to go through the satellite images before I move on to the ice charts. So for example, for this area here, Eastern Greenland, I can select various satellite products. I get low resolution radar, high resolution radar, and optical images. And the idea behind IcySea really was to make it available in low bandwidth connections. So if you're even running on Iridium, you would still be able to access data that usually can, be gigabytes of size. So you want to avoid spending all your data on one image, but rather focus on really specific areas that you're interested in and download only the data that you are, that you're going to need for what you do. So this is why we have this little tile structure. And now with the advent of Starlink and better internet connections on the ship, we also have the option to right click here, get multiple images, and I get to draw a polygon here, for example, for this area, double click, and then I can select optical image, tells me how much data I'm going to use, and then I can download, and will download automatically this entire bioregion. These optical images are really, really useful when there's cloud-free conditions and during daytime, of course. So it's like taking a picture from space. If there's clouds in the way and you can sort of see some clouds here, the gray that covers the ice here, probably clouds. But if they're cloud-free, then you really have really high resolution. You see individual ice flows. And the advantage of these images is that they're taken every day. So you will get a new image every single day. So there should be an update within the next, 10, 15 minutes. So these are from yesterday, the updates about to happen very soon. High resolution, also temporal, but potentially not useful when there's cloud cover. And this is why we have an additional layer here. I'm going to load multiple tiles again. And that's the radar images. I'm going to start with the low resolution. Again, tells you how much data is downloaded. I'll switch that off. And the advantage with the radar images really is the fact that they're independent of cloud cover and nighttime. So if the satellite passes overnight, still going to get information on what's going on at the surface there. There's different gray scales, and that can be tricky, but those images will never show clouds. So you will always look through the clouds and never get obstructed by cloud cover. And you really see, you can now open this one. So you can really use those two tools to compare. You see those structures up here, for example, this ice flow and this sort of edge that's building there. You really see that on both images, and get a more comprehensive view of what's going on. And sometimes, the radar images, they're coming from the European Space Agency at the moment. And if I turn on the age, you will see that this area here is about 20 hours old. And that's sort of the edge of the image. You can see the straight line here. That tells you that there's two different images, and you see that the other image is about almost 2 days old now. So this is where you get the age information. All the layers that we have also have this question mark symbol, which gives you guidelines on what you see, where the data is coming from, what kind of resolution we're looking at, where you can find information on the age, but also basic interpretation guidelines here as well. For example, for the radar image layer, the explanation that you never see clouds, no matter how gray and weird shaped it is. It's always going to be something happening at the surface. Little bit of explanation of what the different gray shades tell you about the kind of ice that you're looking at. And then what I find really useful is the explanation of, you have an example image, and then the explanation of what kind of ice you can see on those images, as those surfaces can look very similar. So there's a little bit of help, and that's really important with IcySea. You're not just using the software, and you're not on your own. If you have any questions, you can always contact us via support@driftnoise. And this is one really nice feature, I think. For example, if you come across such a straight line, you don't remember what it is, you can go and right click on this feature and then go to share location URL. If I click on it, it will have copied a link, and you can send an email with that link. If I open your email and use your link, put it in Chrome, for example, paste it here and hit enter, it will show me exactly what you are looking at, and I'll be able to help you much easier, because I know exactly what kind of feature you're looking at, what area you're looking at. So that's sort of keeping the connection, making it easier to communicate about certain things, and we're always able to help. We have a email shift service, so someone's always watching our emails, even over the weekends and holidays, to make sure that you get the help that you want or need, even during public holidays and weekends. Another layer that we have for the Arctic is the sea ice drift forecast. They're based on a drift model. The explanations again found here in the description. And this really gives you a rough idea of what's going to happen with the ice, based on the winds and ocean currents that can affect drift. And you see those points here. Red is the most sort of today and yesterday, the points, and then going into the future, the white dot at the end of the arrows is the 10-day future. So if an ice flow would start here today, this is where it would be tomorrow, the day after, and then 10 days into the future. So in this area, I would see pretty much southerly drift in about 2 days, sort of slowed down drift, and then it kind of speeds up again. This way you can also really make use of the measure distance tool and say, okay, within 1 day, the ice is going to drift about 7.5 miles, just to give you a rough idea. This layer is updated also daily, and it works like a weather forecast. So the longer you go into the future, the more uncertainty you will get. But it gives you a general idea, and being able to update it really every day will give you confidence in what the drift forecasts tell you. So the next couple of days are usually pretty certain, and then as you go, you should monitor what's going to happen, next week, for example. As I mentioned, all the layers are built for low bandwidth connections, so none of the data is downloaded automatically. You always have to do that yourself. And this is with the refresh button here, for example, or in case of the radar images, and I showed you the radar images here in low resolution. But if I want to update it and also even get high resolution, I can go in and actually see the difference here between those images. It's high resolution down here. Okay, and then maybe I think that's it for the layers that already have been in IcySea probably since the last webinar. IcySea is available in both polar regions, Arctic and Antarctic, but the Antarctic doesn't have all the layers that we see in the north. So we don't have surface temperature, also don't have ice drift forecasts, but there's ice charts for the Ross Sea with the US Ice Service, and I'm going to talk about the ice charts a bit later. But those two layers, the bottom one and the top one, they're not available in the Antarctic right now. Okay, so moving on to the ice charts. Ice charts are really the interpretation of what's going on in a certain area, and it's the official interpretation of the national ice services. In IcySea, we currently have the ice charts from the US Ice Center. If I zoom out, maybe close the other layers so they don't distract us. You see that we now have the sea ice concentration layer available, the sea ice concentration chart, and you see the different polygons that you would know when using the ice charts, and each polygon has its own piece of information about the kind of ice that is in this area. So the red here is 9210 sea ice concentration, and if I left click on this polygon, it will give me the official egg code with all the information and also the description of what the codes mean for people who are maybe less familiar with the numbers and what they stand for in the egg codes. This is available for every single one of those polygons, of course, and the idea with the ice charts is to make them available in exactly the format that people know them to be in. So the National Ice Service provides a certain type of ice chart, and the one that we have in IcySea is exactly the same way. The color code is the same, the information is the same, so people really get to ultimately pick and choose the ice service that they trust the most in that case, or if you in a certain area you prefer one ice service ice charts over the other, and the idea is to select whichever one you want and then make use of the data here. You have stage of development with the US Ice Service as well. So you got the legends down here, and again you can click on the egg code. You can move the picture to the explanation to the side, so you can really look at the rest that's going on here. Really, make the most of what you have. And then And that's, I think, one of the most important things, especially when it comes to the polar code, is that you're able to look at the Polaris risk index based on those ice charts in IcySea. So what we did here is we get all the information, CS concentration and stage of development, and we calculate with the official equation from the WMO, calculate the Polaris risk index for this area. And as you know, this is dependent also on what kind of ship you're operating. So you now get to sort of customize IcySea, and you can go to the settings menu and have the ship properties part down here, and you can select the ice class of the vessel that you are operating. So, for example, ships from Hapag-Lloyd operating PC6, Commandant Charcot, Conan, they're operating PC2. I'm going to switch to PC2 now. I close the settings menu. I can now open the Polaris risk index chart for a PC2 vessel in the Arctic. And there's the different categories: normal operations in blue and green, elevated risk in yellow, and then red and orange for special consideration. And as you see, for for PC2 vessel, none of this should be too difficult. But if I now switch to, say, PC6 vessel, it's going to look very different. So Central Arctic is probably not the right area to go to, but then the region around Svalbard is still accessible. And yeah, the idea is to have really the information that is so valued from the ice services, the official ice charts, with the egg code that people know and are used to, but also combining it with the data layers that we have in here as well. So you can put, for example, the radar images on top of the ice chart. And then in addition to knowing what an area looks like, generally, you can also look at more detailed images of, individual ice flows, open water areas, that sort of thing. So you go from lower spatial resolution really to the highest that's available at the moment. IcySea can also be used as a sort of data provider or a source of gathering the data. So everything that I have selected in here, I can download by going to the export map button up here. And this will allow me to get the data on my computer, and I can use my own GIS system. I'm using QGIS, for example, and I really get to drag and drop all the layers that I've downloaded into my own GIS system, if that's my preferred way of working with this type of data. But IcySea we're trying to build it in a way that combines the advantages of GIS systems without having all the overwhelming number of features, but make it as simple as possible. And as I said in the beginning, the different data layers have advantages and disadvantages. I really want to make sure that by comparing all of them together, you can make the most of all the data that is out there. Okay, I think that's it for IcySea for the moment. I'm going to go back to my presentation real quick to just show you what else is going on. One thing that's really important, people tend to ask, because we always tell people that we're developing new stuff and more stuff is coming. They get worried that it's not ready to use. It is ready to use, but it's never sort of being finished. So we're constantly, as I said, working in the research projects, trying to find new data products that are useful. We're in constant exchange with our users. We want your feedback to improve IcySea. If you're an ice pilot, also a retired one, you have a lot of experience, and we have a lot of ice pilots that give us valuable feedback. We really want that, and we try to develop IcySea really based on that feedback to make it as useful for people going into or close to the ice as possible. So that's sort of the development cycle and process. And then what's next? I mentioned that we are working on including more ice charts from different services as well. The first one that we had is from the US Ice Service. And I'm happy to say, and Kelt is actually here, that we're going to release the Danish ice charts, at least in a test version, for an expedition that will be going on next week. So we'll be able to compare US and Danish ice charts for the area around Greenland next week. And then based on the sort of experience we have with that, and then the feedback from Kelt, we'll be releasing that to IcySea and to everyone as well at some point. We're also in contact with the Norwegian Ice Service. They provided their access to their charts. Then I think that's really relevant for people going also in the Antarctic. The Argentinians have agreed to give us access to their ice charts. So ahead of the next Antarctic season, we hope to have the Argentinian ice charts available as well. And the Canadians are a bit reluctant, but we're in good communications, and we also have example charts already for testing purposes. And I think we'll be adding the Canadian ice charts as well. And then, as I showed in IcySea, you will be able to select really the charts that you want, and depending on where you are, make the most sense for what you do. Secondly, and this is also something that we're going to be testing next week, is that we're integrating more radar images. So the Canadians have a satellite mission called RadarSat Constellation Mission, RCM. And now, as I showed you, the European Space Agency's radar images, they're updated fairly irregularly. So some regions are covered more often than others, and can take up to a couple of days until a new update is available. But with RadarSat, the revisit cycle of the different regions is much higher. So you will be able to even get an image per day in certain regions. And for the west coast of Greenland, for example, I tested that myself. There's images every single day, which is going to really improve what you will be able to do with those charts, because they're really up to date and covering the entire Arctic and also large areas of the Antarctic by now as well. And then sort of diving into the research projects that we're working on, something that we're also trying to include as quickly as possible is classifying those satellite images. We have the help menu, and you can always ask us. But even for someone who looks at those images every single day, you can always come across something that you've never seen, and that can be difficult. And also interpreting what kind of ice you see on a certain image can be difficult. So the idea of this project was to automatically classify an image like this, so you can all see different ice flows here, but it's really difficult to know what type of ice you're looking at. So the idea is to sort of make that into a colorful image where every color stands for a certain ice type, pretty much like the ice charts, but in a sort of higher spatial resolution. And then based on that, you can get even more information on what's going on around you. And then the next thing is that we're trying to overcome the gap between different satellite images. So usually you would get an image. Maybe I got one yesterday. You can see that here. But I know that the area is not covered as often as I would like. So probably I'm going to have to wait for another few days until I get a new image. And we're working on including drift forecasts, but also ship data to sort of animate the ice situation around you. And by that, sort of bridge that gap between new images and make older image more valuable over a longer period of time until the newest image arrives and gives you the most recent view of things. So that's one other project. And this really feeds into the final one. And Lasse, our founder, calls this Google Maps of the Arctic Ocean. You see another classified image here. It's a different color code, but you have multi-year ice in gray, and then new ice in light blue, and dark blue is open leads. And the idea would be that a ship tells us where they are down here, for example, and where they want to go. And then based on the classified image and the drift forecast, we'll be able to animate this, and based on that, suggest the route that makes sense for the type of ship that you operate, avoiding the multi-year ice, going through first and new ice, and then get to the point, but also including the information on how the ice is moving at the same time. And that's really the project that we'll be testing next week in Greenland, to see how good those route suggestions are by now, and whether they're useful for the navigators. Okay, that's what's to come. Again, I mentioned that before, but we really value your feedback. And I see a lot of you have a lot of experience in ice-covered waters, and in navigation as well. So please let us know if you have any suggestions. If you're a new user, IcySea is a subscription-based product, so you buy it for a certain period of time. But first registration comes with a 2-week free trial, and that can be flexible. So if you're planning an expedition or going on a ship, we can make sure that the test, the trial takes place during your expedition, so you can really test it in the field. I think that's the most valuable. And then we would really like to have your feedback and know, what you think is missing, maybe also what's good or can be further developed. And we try to make that happen as quickly as possible, so that is as useful as it can be. And with that, I'm going to finish here, and yeah, I'm really open for your questions.